Let's get ready for the Unit 2 test by going over these practice problems. The instructions for this first part say define variables, write a system of equations, then solve each problem. We always want to make sure that we're showing our work and thinking, and we always want to circle that final answer. So let's take a look at problem number 1. It says at a spring garden sale, Mark bought 3 rose bushes and 7 flats of petunias for a total of $114.75. Cynthia bought 2 rose bushes and 6 flats of petunias for a total of $89.50. How much does each rose bush and each flat of petunias cost? So the first thing we want to do is we want to define some variables. If you want to use X and Y, that's totally okay. I kind of like using, let's go ahead and use R for rose bushes. Okay, cost of a rose bush, and P is going to be the petunias. So petunias, and I'm going to put a dollar symbol right in front of each one of those so we can kind of tell that we're talking about money there. So let's see, Mark bought 3 rose bushes and 7 flats of petunias for this total right here. So this is going to be the equation that represents what Mark bought. Mark bought 3 roses and 7 petunias, and he paid a total of $114.75. And then we're going to write an equation that represents Cynthia. Cynthia bought 2 rose bushes and 6 flats of petunias, and she paid $89.50. All right, so let's go ahead and solve this one. Once we've got this system of equations, we're just going to solve this either by substitution, elimination. I suppose you could do graphing, but that's not very friendly. So here's what we're going to do. We're going to, let's see, we could change both of these into 6s, or we could change both of those into 42s. I definitely like the 6s, so here's what we're going to do. We're going to multiply that one by a 2. And we're going to multiply this one by a -3. Now here's why. If we multiply this one by 2, we end up with, let's see what we've got here. This would be 6r plus 14p. And then if we multiply all the way over here, let's see, we'd end up with, let's see, double that. That would be 228 plus another $1.50. So this is going to be $229.50. If you have to grab a calculator for any of these, go right ahead and do that. And then we're going to multiply the -3 through to each one of these terms on both sides. So this is going to be negative 6r, and then this is going to be minus 18p. And I am going to go ahead and grab the calculator for this one. I'm going to shrink that one down, and let's see what we get here. So if we go ahead and we multiply, let's see, that's going to be multiplying by -3. So -3 times 89.50. And we've got it plugged in there correctly. So that's going to be negative 268.5. And I'm going to do 0.50 since we're talking about money. So negative 268.50. And let's go ahead and combine these. So this is going to go away. That's going to leave us with a negative 4p. And then on the other side, if we just do, well, I'm just going to go ahead and add this. So we're going to take negative 268.5 and we're going to add 229.50. So we end up with negative 39. So this is negative 39. That might worry us for just a quick second because when we've got a negative amount here, but when we divide by a -4, we get p equals, let's go ahead and divide this by -4, and we end up with 975. So 975 right here. So I'm going to go ahead and circle that. And then we're going to come back here and we're going to take this and we're going to plug this into one of these equations. I could plug it into equation number 1, equation number 2, equation number 3, or equation number 4. Remember when we were solving systems, we said it would be silly to plug it into either one of these because these are just larger multiple versions of these original ones. So I'm just going to plug it in a nice easy place. I'm going to plug it into this one right here. So we're going to have 2r plus 6 times p. And we know that p is 9.75, $9.75. And then we have 89.50 right here. So we'll grab the calculator on this one. 6 times 9.75. And we end up with 58.50. So 2r plus 58.50 equals 89.50. And then we'll go ahead and subtract the 58.50. So we get 2r equals, and let's see what we've got here. I'm just going to go ahead and hit subtract, and I'm going to do 89.50. Now, I know I did this in the wrong order, but what that does is it gives me a quick way to get the answer. I just know that I need to change the sign of that. So this is going to be a 31, and we're going to divide by 2, so we get r is equal to, well, that's going to be 1550 on that. So 1550. So there's the answer for this guy right here. Now, we know that the R is roses and P is petunias, so we're going to say this. We're going to say roses, cost. Let's see, that's $15.50. So $15.50. And petunias, petunias are, let me get rid of that there. Petunias are, what do we say, $9.75. So $9.75. Now, if you don't know what a flat of petunias are, that's that big flat tray where they put maybe 6 or 8 groups, little bundles of petunias on there, but that's what that is. No matter though, we've got the cost of the roses at $15.50, and we've got the cost of the petunias at $9.75, so we're all set to go. These do take a little bit of time to work on. So we've just got to make sure we're careful and show all our work. So let's take a look at this next one. I'm going to go ahead and make this bigger now. So we've got John. He can fly his ultralight airplane 324 miles in 4 hours with the wind, but against the wind, the same distance takes him 6 hours. Find the speed of the plane and the speed of the wind. So I'm going to do this. I'm going to say P equals the speed of the plane and W equals the speed of the wind. A perfectly good way to do it if you want to write it off here, and if you want to use X and Y, that's totally okay. Now remember, distance equals rate times time. So the distance that you go has to do with how fast you're going times the time that you go that fast. And the rate, when we're talking about something in a current or wind or something like that, it's the speed of the plane plus or minus the wind, or it's the speed of the boat plus or minus the current and things like that. So here's what we're going to do. Remember, we add the speed of the plane and the speed of the wind together with the wind. So we're going to do the plane plus the wind. That's going to be its rate. And then, so there's the rate, and then we're going to multiply it by the time. The time in this case was 4 hours, and it went 324 miles. And we're going to set up the same thing on the return trip. The return trip was exactly the same distance, so 324, but this time the plane was working against the wind, or the wind was working against the plane. And remember, we've always got to do it the plane or the boat or whatever it is, plus or minus the wind or the current, and it took it 6 hours. Okay, so it took him 6 hours on the return flight. Now, when you've got something set up like this, we could find a little bit of a shortcut, and I'm going to show you that here in just a second. But this whole idea of distance equals rate times time, really valuable idea. It can help us solve more complicated problems. So please get it set up like this, and then we'll talk about how we can make a nice, easy step on each one of these. The nice, easy step here is, you'll notice that we would have to take this and distribute the 4 through, but what happens if we take 324 and divide it by 4? So in other words, we're going to take both sides here and we're going to divide them by 4. Well, if we divide this side by 4, the 4 is going to cancel, so that's going to end up with a P plus W equals, and then we'll just grab the calculator here. We're going to do 324 divided by 4, so 324 divided by 4, and we end up with 81. So that's going to be 81 here, but at the same time, I'm going to go ahead and get rid of that 6. So let's see what we get there. Do we get a nice number when we take 324 and we divide it by 6? Hope we do. Yep, we get 54. So this is going to be 81, and then when we divide this side and that side by 6, we get P minus W equals 54. Let me just pull that up and double check. Yep, we had 54 there. Okay, so the cool thing about this is, and this does not work on every single one of these distance problems, but if we set it up this way, we can look for shortcuts like this. So you'll notice that we now have P plus W equals 81, P minus W equals 54, and this is all set up for elimination. So we're just going to combine those together. We get 2P on this side, and then on the other side, let's see, that's going to be a 5, and that's going to be a 135. Yep, we get 135 there. And then we're going to divide by 2, so we get P equals, if you want to, grab the calculator, 135 divided by 2. So we end up with 67.5. So 67.5, okay, that's P. Now we need to figure out what W is. So let's come back here, and probably the easiest place to plug it in would be this guy right here. So let's just plug it in there. So we get P plus 67.5. Whoops. So we get 67.5. We're putting that in place of the P plus the W equals 81. So we'll subtract 67.5 and we get W equals, so let's come back here to the calculator, and I'm just going to subtract the 81. So that gives us 13.5. Again, I did these in the wrong order, so it does turn out to be negative. So I'm going to get 13.5 here. Just change the sign of that. Now remember, P stands for the plane, W stands for the wind. So we're going to write this down. We're going to say plane can go 67.5 miles per hour. It was in miles and hours there. And wind is, let's see, what would the wind be? Wind was 13.5. Wind is 13.5 miles per hour. All right, so we can go ahead and circle that. That is the answer. We've done everything they asked. We've declared the variables. We've set up a system. We solved the system. And then we didn't just say, oh, P equals this and W equals this. We actually wrote down in words what the answer to the problem was. So let's come down here and take a look at the last one on this page. So Sarah's student loans totaled $10,500. So that's how much she borrowed. Part was a plus loan made at 6.5% interest, and the rest was a Stafford loan at 4.5% interest. After 1 year, Sarah's loans accumulated $650 in interest. What was the original amount of each loan? Well, what we need to remember here is we need to remember that interest, okay, in this particular case, we're talking about simple interest. Interest is equal to the principal times the rate times the time. And there's a really important thing right here. It says the time is 1 year. So T equals 1. So it's just going to be the principal, the amount that she borrowed times whatever the interest rate was for each one of these. So we need to come off to the side here and we need to declare some variables. So let's say X equals the plus loan and Y is equal to the Stafford loans. These are actually real things. Okay, so let's see. It says the total amount that she borrowed was $10,500. So we're going to do X plus Y is equal to $10,500. And then we've got to figure out what the interest was. Okay, so the interest on the plus loan, that was at 6.5%. And the plus loan is X. So we're going to do 0.065 times X. Remember, to change this to a decimal, we move it over two places. That would be 0.065. And then this is going to be 0.045 times Y. I didn't make those things line up very well. And then the total interest, it says she accumulated $650 in interest altogether. So this is going to be $650 right here. So this is the right system to solve. Now we want to go through and we actually want to figure out what the answer is. How much did she put in the plus category and how much did she put in the Stafford category? So I'm going to do this. I'll change colors on this one right here. I'm going to multiply this one by negative 0.045. Now I'm going to go ahead and distribute through here. So here's what we're going to get. This is pretty easy on these first two. This is going to be negative 0.045 times X. This is going to be negative 0.045 times Y. And you can see why we multiplied by negative 0.045 because we wanted to eliminate the Y's. That was the smaller one, so that's generally a good idea. Now we're going to do negative 0.045 times 10,500. So we are going to get a negative, and now I'm going to pull up the calculator and take a look here. So this is going to be negative 0.045 times 1,500. So let's see what we get here. So $472.50. So $472.50. $472.50. Now we'll go ahead and combine the two of these. So again, this is a copy of that original equation. We've just got a multiple there. So this is going to be 0.065 minus 0.045. So that's going to be 0.02. And if you stop and think about it, we're really finding the difference between these two interest rates. 6.5% minus 4.5% would be 2%. So this is going to be 0.02x. Those go away. We don't have any y's anymore. And then we have 650 minus 472.50. So I'm going to grab that calculator again. Notice that we've still got that number in there. So I'm just going to go ahead and add the 650. And we get 177.5. 177.5. So $177.50. So we're going to divide by 0.02. 0.02, 0.02, and those are going to cancel, so we end up with x is equal to, grab that calculator again, and I'm just going to hit divide because that is the last number that was in there, divide by 0.02, and we get this 8875. So 8875. So we're going to go ahead and take that one, and probably the best place to plug this one in, of course, is that first one right here, because there's very small coefficients and no negatives here. So 8875 plus y is equal to 10,500. So all we have to do is subtract the 8875. So I'm going to go ahead and pull up the calculator and let's see what we get here. We're going to do the 10,500 and we are going to subtract 8875. So we end up with 1625. So we're going to get y equals 1625. So I'm going to go ahead and circle that. And now we need to make sense of the answer. So remember, I went ahead and used x's and y's instead of a p and an s on this one. You could do whatever you want, but x represents the plus loan and y represents the Stafford loan. So we're going to write this. Let's see. Let's go ahead and write down 8875 on the, let's see, that was a 6.5% plus loan. And let's see, the other amount is going to be the 1625 on the 4.5% Stafford loan. So we'll write Stafford loan right here. And then we'll go ahead and circle this and we'll have our answer right there. Okay, so we've got that taken care of. And remember, we did solve for x and y, but we put it back in terms and wrote it in words as far as what the answer was here. Now, you could double check and make sure that you got this right. We know that we're pretty sure that we got this one right using that equation right there. We plugged back in and we figured out what that y was 1625. So we know that these two add up to the 10,500, but you could double check this by taking the 0.065 times the x, which was 8875, and the 0.045 times the y, which was 1625. So I'm going to pull up the calculator really quickly and do that. Okay, so I went in and typed that into the calculator. There's the 6.5% times the 8875. There's the 0.045, the 4.5%. And we'll go ahead and pull that up, times the 1625, and we do get that answer of $650. So that is the right answer to that one right there. Okay, we're now on the back side. We're on problem number 4. This is a mixture problem, so we've got a trail mix is made by combining raisins that cost $4.20 per pound with granola that costs $2.20 per pound. How many pounds of each should be used to make 40 pounds of a mix that costs $2.75 per pound? Well, there are several different ways to solve a problem like this. One way you could do this is by setting this up in a table. So let me show you how to set up a table here. What we're going to do is we're going to keep track of, let's see, this would be raisins, and then we'd have, let's see, we have granola, and then we have our mix all together. And we could keep track of just the amount. So let's use R for raisins and G for granola. And it says we're going to have a 40-pound mix altogether. And on this one, it says this is $4.20 per pound per raisins. So this is like the amount right here. Okay, and then this is going to be the dollars for each one of them per pound. Okay, in fact, let me just go ahead and write price on this one. And then we'd keep track of the dollars for each one of those amounts, okay, for that amount. All right, so it's $4.20 per pound here, whoops, $4.20, and it's $2.20 per pound here, and we want it to be $2.75 per pound when we're all done. Well, this right here is an equation, and we're going to get an equation about the money that's involved here. So what we'd do here is we'd say, well, if you bought this or used this many pounds of raisins at $4.20 per pound, this would be 4.20 times the number of pounds of raisins, and this would be 220 times the number of pounds of granola, and this would be 2.75 times 40, because we know we've got 40 pounds altogether. Now, if you need a table to set that up, that's totally okay. This right here, and I'm just going to go ahead and highlight that, that is one equation. This is just about the pounds that we're dealing here, the amount of each one of these. And then this right here is going to be another equation. It's about the money, okay? Now, this middle one right here, it's just kind of a way to keep track of what's going on here. We've done this with percentages and stuff like that. But let me show you one way that you can solve this without using a table, and it kind of amounts to the same thing. What we would do is we would say that, well, we're going to take the pounds of raisins plus the pounds of granola, and it's going to equal 40. So raisins plus granola equals 40 pounds. And then we're going to take each one of these and we're going to multiply them by how much each one of those is worth. So a pound of raisins is worth 420, so we're going to do 420 times R. And a pound of granola is worth 220, so we're going to do 220 times G. And each pound of those 40 pounds is worth 275, so we're going to do 2.75 times 40. So this is the same thing that you'd end up with over here. It's just that some people like organizing it at a table, and then other people like doing it a different way. Either one is fine. I like both of them. So let's go ahead and finish solving this because we do arrive at the same equation or set of equations either way. So I'm going to take this one and I'm going to write r plus g is equal to 40. And then on this one, we're going to write 4.20r plus 2.20g equals, and I'll grab the calculator for this one. Let's see what we get here. This would be 2.75 times 40. And we end up with 110. So we've got 110 right here. Now, I do want to take just a quick second to talk about two things. Number one, I did forget to write down what our variables were. So remember, I've kind of got that right here, but we could just say R is equal to raisins, G is equal to granola. The other thing is, when I'm dealing with a money problem, I really like keeping track of both of the decimals here. That's why I wrote the 4.20 for $4.20 and the 2.20. If you wanted to do the 4.2 and the 2.2, that's totally okay. But realize when you're dealing with money, we do have to have both those decimal places. It has to be out to the penny, out to the hundredths place, if you wanted to say it that way. So here's what we're going to do. I'm going to take this one, and I'm going to go ahead and eliminate the smaller one, the one with the g. So I'm going to take that first equation, and I'm going to multiply it by negative 2.20. So negative 2.20. So this is going to give me negative 2.20r minus 2.20g, and then I need to multiply that by 2.2. So let's grab the calculator. That's going to be 2.2 times 40, times 40, and we end up with 88. So that's going to be 88, and it does need to be negative, okay, negative 88. So when we combine those, let me get rid of that line right there and put a red one there because that's the way I typically do those. Let's see. So this is going to be 2r. Those are going to go away, and then we get 110 minus 88. Well, 110 minus 88 is going to be 22. You can double check me on that. Then we're going to divide by 2, so we get r equals 11. So we know what r is, and we're going to take this and we're going to go plug it back in right there. So we end up with 11 plus g is equal to 40. So we'll subtract 11 and we get g is equal to 29. So we've got our two answers right there. And remember, R stands for raisins, G stands for granola. So we're going to use, and it said how many pounds of each should be used. So we're going to use 11 pounds of raisins and 29 pounds of granola. Okay, so we'll circle that, and that is our answer. So we're done with the story problems. Now let's slide down here and let's take a look at these. Here we need to solve each system of equations by graphing and label a point where the lines intersect. So hopefully that turns out to be easy on these. If it's not, we might have to solve a system of equations or something. So let's go ahead and take a look at this one. This is going to be a solid line at x equals positive 3. So that's going to be right here. Nice solid line at x equals 3. Remember that if you've just got one variable, it tells you which axis it crosses. So it crosses the x-axis at 3. We've got a vertical line right here. And then we'd shade left, so we'd shade on this side over here. So I'm just going to mentally kind of keep that in mind. And then we've got y is greater than or equal to greater than negative 2x. So if I had to, I could put a 0 on here. So that means that's where it crosses the y-axis. So we're going to go down 2 and over 1, down 2 and over 1, down 2 and over 1. So it looks like this. And then I just need to keep in mind, well, what type of line is this? This is a dotted line. So if we do a dotted line, that's going to come down to here, like this. And remember, I really don't need to go any further than that because we already said that we were going to be shading on this side of the vertical line. And we're going to be shading above the dotted line. We put our pencil on the line, and then if y is greater than that, we go up. So this is what we're going to be looking at. This is the shaded region right here. If you wanted to make this look really nice, we could get rid of that line and just go from here straight up. Remember, we've got a solid vertical line right here, and we've got a dotted slanted line right there. And then it did say we needed to graph and label the point where they cross. So these two lines intersect right here. So that intersection point would be over 3 and down 6. So this would be 3, negative 6. And there we go. That's all there is to it. I'm going to go ahead and circle that one so we know the point of intersection. Let's look at this one. This is going to be a dotted line. Crosses the y-axis at 0, so crosses right here. And the slope is 4, so we're going to rise 4 and run 1. We're going to rise 4 and run 1. down 4 and back 1, down 4 and back 1. And this would be the dotted line right here, and we would be shading below that, which kind of looks like it's on the right side because this is a pretty darn steep line. Okay, but we are shading below that dotted line right there. And then we're talking about this one here. We've got, let's see, we've got y is less than or equal to, so it's going to be a solid line. Slope would be 1 on this one, and then it's going to cross at -3, so it's going to look like that. And this is a solid line. Okay, whoops. And it goes like that, and then we'd come over here. So they definitely intersect at that point right here. So we're talking about below this line right here, and at the same time below this one. So that's going to be this solid line right here over to that intersection point, because remember we were underneath that, that steep line right there. And then we have a dotted line right here, and it's underneath both of these. So what we're talking about is this shaded region right here. And then they happen to cross at a nice point like this. This is going to be the point -1, comma, -4. -1, comma, -4. That looks pretty good right there, so I'll go ahead and circle that. So let me slide down here and let's take a look at these next couple. We do have to solve a couple of these so we can put these in graphing form. So here's what I'm going to do. I'm going to do something kind of clever on this one, and you may have seen this before. We could move the x over to the other side and then divide by a negative. That's totally okay, that's acceptable, but remember, when you're working with an inequality, if you divide by a negative, you have to switch the direction of the inequality. So that might be kind of a hassle. So here's what we're going to do. I'm just going to swap places with the two of those. I'm going to move this by adding y, and I'm going to move this by subtracting 4. So here's what we end up with. We end up with x minus 4. And remember, we just added and subtracted, so it's not going to change the direction, so we end up with this. So we end up with y is greater than or equal to x minus 4. Now, if you want to do a big pancake flip and flip the entire thing over, you've got to take that big mouth right there. It's got to still be toward the y, and then we've got an x minus 4. Now, if you just wanted to move the 4 over by subtracting and then divide everything by a negative, that would be totally okay. Not a problem with that. So we're going to graph this one, and we're going to graph this guy right here. This one's a little more complicated, so we're going to subtract x. So we end up with 3y is less than negative x plus 6. And then we're going to divide everything by 3, so that's going to leave us with y is less than or equal to, or sorry, just less than on this one, just a strict inequality there. When we divide by 3, we get negative 1/3 x, and then we get plus 2. So these are the equations that we're going to graph, so we've got to be kind of careful with those. So this one's going to cross at -4 and have a slope of +1, and this one's going to be a solid line. All right. So we get something that looks like that. I'm not going to draw all of that yet. And then the other one crosses at 2, so crosses right here, and it has a slope of -1/3. So down 1 and over 3, down 1 and over 3. And you might notice immediately that we have a little issue right here. These are going to cross somewhere about right there. So we're going to need to find that, but we'll do that in just a minute. Let's go ahead and finish the graphing. We're talking about the points that are greater than this guy right here. So greater than this line, this steep line in a positive direction. So we're talking about above here. So we don't need to worry about anything down here, just above here. So we're on the top of that slanted line right there. And then the other one, it's less than this one. So it's less than the dotted line right here. So I'm going to do this. I'm going to do a dotted line on that guy right there. And again, these don't have to be absolutely perfect, but you do want to make them look as nice as you possibly can. So we've got the solid line right here with the positive slope. We've got a dotted line with the negative slope. We're talking about the ones that are bigger than the positive slope and less than the negative slope. So we're talking about this stuff right in here. Okay, so there's the answer. And now we need to find the point where those lines cross. Now for this one, I am going to go ahead and clean this one up. I'm going to go ahead and erase those. Now here's the cool thing. If you've written both of these in slope-intercept form, we know y is equal to this stuff and y is also equal to that stuff. Well, this is set up for elimination. So what we can do is we can just set the two of those equal to each other. Remember, we don't need to worry ourselves about the inequalities because we're literally trying to find that point where the lines cross. So we'll just treat them like they're lines. And here's what I'm going to do. I'm going to move this over to this side by adding 1/3 x. And you could clear the fractions if you wanted to. At the same time, I'm going to add 4. So we get, this is 1 plus a third, that's going to be 4/3. 1 1/3 is 4/3. 4/3 x is equal to 6. And then we've got a fraction in front of the variable, so I'm going to get rid of that by multiplying by the reciprocal. The reciprocal is 3/4. And I'm going to do a little bit of cross-canceling. 2 goes in here twice, 2 goes in here 3 times. So this is x is equal to 9/4, or sorry, 9/2. 2 on the bottom. We cross-canceled that. So we get 9/2, 4 1/2, which looks like that's right. Okay, so this point right here is 9/2. We certainly wouldn't want to write that as a mixed number. So let's find the other one that it goes with. And so for that, we're actually just going to take this and we're going to plug it in right there. So if I take that and I plug it in right here, we end up with 9/2 minus 4, or that would be 4 1/2 minus 4, so that would be 1/2. And you'll notice, gosh, that looks like it's about 1/2. So we are in good shape there. All right, let's hope this last one works out a little bit easier. This one, you'll notice that both of these are going to be solid lines, so that's kind of nice. And this one has already been solved for y, so it's already in slope-intercept form. This one we need to do a little bit of work, so we're going to subtract x, and then we're going to divide by 4. So that's going to leave us with y is less than or equal to, this would be negative 1/4 x. Okay, this would be negative x divided by 4 here. And then we take the 32 and divide by 4, and that's going to give us an 8. And again, if you had to write this out and show your work for every single step here, there's nothing wrong with that. There's the plus 32, and then we divide everything by 4. So there's our 1/4 x, our negative 1/4 x, and there's our plus 32. So we're going to graph this line, and we're going to graph this line. And again, they're both solid lines, and they happen to be both less thans. So this one's going to cross at negative 3 and have a slope of 5/2. So we're going to go up 5 and over 2. We're going to go up 5 and we're going to go over 2. We're going to go down 5 and back 2. So that's going to be a solid line there. I'm going to wait just a second to draw that. And we're talking about below that line. So we're shading in below here. So we're talking about this region in here. So I'm going to go ahead and kind of shade just with some of this stuff right here. That'll be easy to erase. And then the other one, this is going to be y is less than or equal to negative 1/4 x plus 8. So that's going to cross at 8 and has a slope of negative 1/4. So that's going to be down 1 and right 4, down 1 and right 4. And we're talking about below there. So I'll shade in this one like that. And we want both of these to be true. So the word that would technically connect the two of these inequalities would be the word and. So it's going to be this stuff right in here. So I'm going to go ahead and erase that. And I'm going to start drawing my solid line. So this is going to be a solid line from here to here. Should probably make sure I put arrows on the ends of each one of those. And from there to there. And then we just shade in this stuff right here. That's what it would look like. And we just need that point right there. So that's going to be over 4 and up 7. So this is 4, 7. There's the point where they cross. Okay, let's take a look at the last problem. It says a carpentry shop makes coffee tables and dinner tables. The material for coffee tables costs $60, and the material for dinner tables costs $100 each. The shop can spend no more than $4,000 for material for each week. The shop has to complete at least 10 coffee tables and 16 dinner tables each week to fill standing orders of their biggest clients. So standing orders, they just have an order. They always need that many of each one of those for their biggest clients. And the shop can produce at most 52 pieces of furniture each week. The shop makes a profit of $290 on coffee tables and $270 on dinner tables. And it says, so they've declared variables for us here. X is the number of coffee tables and Y is the number of dinner tables. So we need to write down a system of equations. So that first sentence right here, after kind of the setup here, we're talking about money here. So we have to pay money in order to get the material to make a coffee table and pay money to make a dinner table. And they can't spend any more than $4,000. So if X is the number of coffee tables, we're going to take the cost of a coffee table, so that's $60. And we're going to multiply that by X. We're going to take the cost of the dinner tables, $100. We're going to multiply that by Y. And it says they can't spend any more than $4,000. So that's going to be less than or equal to $4,000. The shop must complete at least 10 coffee tables. So the coffee tables is X, so they've got to complete at least 10. So that means the number of coffee tables has to be greater than or equal to 10. And the number of dinner tables, that's going to be Y, has to be greater than or equal to 16. And then we get into this last one right here. It says the shop can produce at most 52 pieces of furniture. Now, that's a little bit tricky depending on how you're reading this and thinking about it. So if they're making furniture, they're only making two things, and they can't make more than 52 pieces altogether. So we would take the number of coffee tables, add it to the number of dinner tables, and that can't add up to be more than 52. So it's going to be x plus y is less than or equal to 52. All right, now we've got a profit function right here, so let's go ahead and write down what that is. So we're going to have 290 times each one of the coffee tables that they make, plus $270 times each one of the dinner tables that they make. So we're going to go ahead and move this around just a little bit so we can graph these a little bit more easily. So the first thing I'm going to do is I'm going to subtract 60x from this. So this is going to be 100y less than or equal to negative 60x. And then that's going to be plus 4,000. We're going to divide by 100. Thinking ahead too much. Divide by 100. So this is going to be y is less than or equal to. Now, you might be tempted to change this into a decimal. You could if you're going to solve this on your calculator, but you'll notice that we need to actually graph this below. So what I'm going to do is I'm going to cancel the two of those off. So that gives me 6 over 10, and I'm going to reduce this by a factor of 2. 2 goes in here 3 times, so this is going to be negative 3 over 5. It's like reducing 6 tenths is the same as 3/5, so negative 3/5 x, and then this is plus 400. Oops, sorry. Cancel the 2, so it's just 40. Okay, so we're going to graph that one. I'm going to move this one around. This is going to be y is less than or equal to. If you just move that to the other side, you just get negative x plus 52. And then, of course, we've got these other guys right here. So x is greater than or equal to 10, and we get y is greater than or equal to 16. So we're going to take these, and we're going to need to graph these, and we're going to need to make sure that we label and scale the axes. So I'm going to slide this down and see how much room we've got here. So I'm going to need to shrink this a bit. So we'll go ahead and shrink that so that I can still see the original problem. And let's see, a couple things here. We need to make sure that this goes up to at least, well, let's see. One's going to cross at 40, the other one's going to cross at 52. There's no way we've got 52 boxes here, so we certainly can't count by 1. So let's see. If we did 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 4, 6, 8, 30, 2, 4, 6, 8, 40, 2, 4, 6, 8, 50. 52 would put us right at the top there. So we're going to count by 2 on each one of those. And I'm not going to do 2, 4, 6. I'm going to do this. Let's put a 4 right here. Let's put an 8 right here, a 12 right here, a 16. We're skipping a box and we're counting by 4 basically. So this is going to be 20, 24, 28, 32, 36, 40, 44, 48, and 52. So that's good. We ended there. Now, if we can do this, it does make it easier if we do the x and the y axis. If we do those both using the same scale, that's going to make it easier to graph these by hand, but we can double check this on the calculator. So let's do, this is 4, this is 8, this is 12, this is 16, this is 20, 22, whoops, not 22, 24, 24, 28, 32, 36, and 40. So we've got this scaled. Remember, we want to label this also. X was coffee table, so I'm just going to write coffee right here, and I'm going to write dinner right here. Tough to fit all this stuff in there. And then let's go ahead and graph this. Let's do this one first. So this one's going to cross at 40, so we're going to cross right here. And then we have to go down 3 and over 5. Now, if we went down 3, 3 would be at 37. That would be right here. And then 5 would be about right there. We can make this a little bit easier because because these are both scaled the same, we are literally just counting boxes. So we're going to go down 3 boxes. We're going to go over 5 boxes. And because each one of those counted for 2, you'll notice that we're right in between here. We're at 10. So we'd go right here. We're going to go down 3 and over 5. Should be at 20, which we are. Down 3 and over 5. We're right there. And then we'll go down 3 and over 5, and we're right there. So we've kind of run out of room. Hopefully we're in good shape there. This one is, let's see, crosses at 52, slope of -1. So we're going to cross right here. And we're basically, again, we're just going to go down that many boxes. So we're going to go down one box. So we're basically this nice 45-degree angle right here. So I'm just going to put those dots in here because we are going to run into this other one at some point because we've got a little bit steeper line. We run into it right there, and then we go like this. Okay. All right, so that's what it looks like. And we're talking below both of those lines. So this is going to be a solid line here, and that's going to be a solid line here. Okay. And then we've got these other guys right here. So this is x is greater than or equal to 10. So let's find 10 in the x direction. So we're talking about everything bigger than this right here. Okay, so we've kind of got this little region defined right here. And then y is greater than or equal to 16. So 16 would be right here. So we go like that. Okay. Now, that defines this feasible region right here. So let's look at all these intersection points. So we've got this one, this one, this one, and this one. So we've got 4 intersection points. And this right here is our feasible region. These are the points that we're going to check. So we've graphed the inequalities, and now we get to the stuff that's a little bit easier. We've done all the hard work. This point right here is 10 on the x, so this would be 10, 16. And I'm actually going to write these over here because it says what are the vertices of the feasible region. So this would be 10, 16. Let's see, the next one is going to be, let's go this way, 10, that would be 34. 10, 34. And this intersection point right here is, let's double check here, this would be 30 and 22. Okay, so 30, 22. And this one right here would be 36, let's see what we would be there, 16, 36, 16. Okay, now you'll notice that these two guys right here, these are two where we actually use all of the capacity of the shop because they said they could make 52 pieces of furniture. Here we're only making 26 pieces of furniture. We're really not making as many as we can. And then it says what's the maximum and minimum profit. Okay, so what I'll do next is I'll just take these. Okay, so we've got those right there. So I'm going to box those in. But then remember what we want here is we want to figure out what the max profit is. So this is going to be 290x plus 270 whatever y is, and then that's going to equal the profit. So I'm going to grab the calculator, and we're going to plug several of these in, and we're going to see what we get. So if I plug each one of these in, let's see what we get here. So I'm going to grab that calculator, and I'm going to clear this off, and here's what we're going to do. We're going to do 290 times 10 plus 270, 70 there, times, let's see, 16. So again, what I'm doing here is I'm just plugging each one of those in here. So it's 290 times x is 10, and then 270 times y is 16. So we get this answer right here. So we get 7220, okay? So 7220. And the cool thing about this is I'm just going to recall this. All we have to do is change the numbers. And notice that on this one, the only thing that changes is we make more dinner tables. So I'm going to come back here, type in a 34. We end up with $12,080. So this is 12,080. Better make that look right. $12,080. And I'll recall these other two guys right here. Recall that. Type this in as, let's see, this would be 22. I'll just do this as I'm going backwards. And this one's going to be a 30. So 30 for x, 22 for y. Go ahead and hit enter. We get 14,640. And while I'm over here, I'm just going to pull this up, and we're going to change this one to 16. So 16, and the other one needs to be a 36. All right, so let's check that. Okay, so we get 14,640 for this one. So 14,640 for that one. And then the other one was 14,760. So 14,760. All right, now if we go down to the bottom of the page, what it wants to know is what is the maximum and minimum profit, and how many of each tables produces that profit. So let's take a look. The smallest profit was right here. So there's the minimum, and here's the maximum. Well, it should kind of make sense that the minimum occurred at 10, 16 right here, where we made the fewest number of tables. Remember, we said we only made 26 tables altogether. And then on this one right here, a little bit surprising. A lot of times we end up with the maximum profit or revenue coming from this point right here. On this one, just because of the way the profit function worked out, it's actually better if they make more coffee tables than anything else. So that's where they produce the maximum profit. So I'm going to go ahead and enlarge this right here, and let's write down what the answer is. So the answer on this one was 10 coffee tables and 16 dinner tables produced $72.20. Okay, so min of $7,220 when they make, that was 10 coffee tables and 16 dinner tables. Okay, so I'm going to go ahead and circle that one right there. And then max of, what do we have there? $14,760. $14,760 when they make 36 coffee tables and 16 dinner tables. All right. Now, that's kind of like the bare minimum you could get away with. I did answer both questions, used a couple abbreviations there and stuff like that, but I think we should be in good shape. All right, I know that's a lot of work. This is really good quality stuff, good stuff to practice. If you can do this stuff, boy, you can do just about anything. All right, good luck on the test.